Its surveying capabilities are over 1,000 times faster than Hubble and can chart 200 times more sky in a single image. And what would take Hubble 2,000 years to process, Roman can do in a year. The images it captures will be so large there is not a screen in existence large enough to show them. Roman will give the Earth a new atlas of the universe. And I think it's worth pausing for a moment and just think about how really incredible that is. The farther we reach into space, the greater our curiosity to understand the great unknown. Nancy Grace Roman Space Telescope is now fully assembled, has completed testing, and is undergoing the final preparations before it'll be shipped to Kennedy Space Center to soon take its place among America's great observatories alongside Hubble and the James Webb Space Telescope. Now, our team dedicated over a decade of their lives and millions of hours to make this project a reality. Because of their hard work, I have the privilege of announcing today that we are now targeting an early September launch.
Previous speakers have mentioned that Roman can survey the sky 1,000 times faster than Hubble. So to put this into context, 1 month of Roman observations would correspond to a century with Hubble. If we were to take the single image that is produced from our main survey and try and fully display it with a set of 4K TVs, you'd need more than 500,000 4K TVs. And just to give you a sense of the scale of that, if I was to lay out those 4K TVs, it would cover 45 city blocks. We have a second instrument, the Roman coronagraph. And I think of this as doing magic with physics. We take advantage of the wave properties of light to cancel out the light of a bright star so that we can image faint planets next to it. To do this magic, we have to have an optical system that can adjust itself to maintain sufficient precision. This will be the first time we've had a system in space with this kind of active optics, and it will set us on a path for future observatories to do extraordinary new things. What makes me most excited about Roman is its discovery space. If we have 2 billion galaxies, it means we have 2,000 one in a million objects. We're going to be surveying patches of the sky, going back over and over and over again to find new things that go bump in the night. I very much hope, and in fact expect, that the most exciting science from Roman is going to be the things that we didn't expect, that we couldn't predict, but that will set the new, deep questions for future missions to address. That survey will detect over 2 billion galaxies. And we'll use it to study how the structures in the universe, the stars, the galaxies, the structures of galaxies, grew and evolved. We'll also study how the universe itself has expanded over time. And these are the keys to unlocking the fundamental nature of dark matter, dark energy, and the fabric of the universe itself. Periodically, we'll point towards the center of our own galaxy and monitor hundreds of millions of stars. But we're not going to just image millions of stars. We're going to find a treasure trove of exoplanets, up to 40 times more than are known today. So think of this as the largest census we've ever done of planets in our galaxy.
Hubble gathered 172 terabytes of data in its first 30 years. Roman will downlink 1.4 terabytes of science data every day. That means it will potentially have about 2,500 terabytes over the course of its 5-year mission, and basically gathering like a hypothetical stack of science papers that would reach up to beyond the moon, maybe even as far as Artemis 2 went. We've already confirmed today over about 6,000 planets. Roman will discover tens of thousands of new planets outside our solar system. It will reveal billions of galaxies, thousands of supernovae, and tens of billions of stars. Roman will help us address the question of how common solar systems like ours actually are, while also literally expanding the human mind to what the universe contains at an astounding rate. Roman isn't just doing Hubble and Webb science faster, however, and I know it's very easy when we focus on the speed, it's doing fundamentally different science that could not be done with either observatory. Together, the 3 missions will complement each other, giving us a more complete picture of the cosmos and advancing our understanding of the universe. Right now, Roman has the most stable telescope and the absolute best coronagraph that has ever flown in space.
Current observations hint that our standard model of the universe is incorrect. Roman will be able to confirm these and set us on the path to understanding what's right.
The first reference I'm aware of is back in 1925 that it was suggested that we needed a telescope in space. I've read that one of the astronomers at Princeton, this was probably in the 30s or 40s, said that when he died, he wanted to go to heaven and take a telescope with him. And so when the possibility of a telescope in space opened up, astronomers jumped on the idea.
The Nancy Grace Roman Space Telescope, a $4 billion machine that is genuinely one of the most powerful things humanity has ever built, and somehow most of you have never heard of it. And no, that's not clickbait, and it's about to make Hubble look like a pair of dollar store binoculars. NASA really did spend decades building this and just kind of whispering about it, so sit down, let's fix that. What is this telescope actually? All right, let's talk science. Don't worry, I'll make it fun. The Nancy Grace Roman Space Telescope, let's call it Roman for short because the full name is a mouthful, is an infrared space telescope. Same mirror size as Hubble, 2.4 meters across. But here's where it gets wild. Hubble is like a really impressive telephoto lens. It zooms into small patches of sky with incredible detail. James Webb is basically Hubble, but on steroids. It sees fainter, deeper, and further back in time than anything before it. Roman is the wide-angle cinema camera to their telephoto lenses. In a single shot, Roman can photograph a patch of sky 100 times larger than what Hubble can capture with the same level of sharpness. It's packing an 18 detector, 300 megapixel camera. For context, Hubble's detectors were 1000 by 1000 pixels. Webb's are 2000 by 2000. Roman's 4000 by 4000 pixels, and there are 18 of them. One scientist described it like this, where Hubble looks at a single blade of grass, Roman zooms out and shows you the entire field. Roman can survey the sky 1,000 times faster than Hubble. Let that sink in. In its 5-year primary mission, it is expected to map over 1 billion galaxies, discover over 100,000 new worlds, image hundreds of millions of stars. 1 billion galaxies. I've watched 5 seasons of a show and haven't even met a billion characters. What is it actually hunting? So what's Roman actually going to do with all that vision? Great question. 3 big things. Number 1, dark energy. Here's a fun fact that should keep you up at night. The universe is expanding. We knew that, cool, fine, whatever. But in the 1990s, astronomers discovered it's not just expanding, it's accelerating. The universe is getting bigger, faster and faster, like someone put the cosmos on a treadmill and cranked the speed up. The thing causing this, we call it dark energy. And here's the terrifying part. Dark energy makes up roughly 68% of everything in the universe. And we have absolutely no idea what it is. Roman is going to map how galaxies cluster across space and time, trace supernova explosions, and use something called weak gravitational lensing to try and figure out what dark energy actually is. NASA scientist Nikki Fox put it perfectly. Why the expansion of the universe seems to be accelerating is a great mystery. There is something fundamental about space and in time we don't yet understand. Roman was built to find out. Number 2, dark matter. While we're at it, that other invisible thing making up 27% of the universe, also dark matter. We can't see it. We only know it exists because of how it bends light and affects the gravity of everything around it. Roman will watch how background galaxies get warped by clumps of dark matter scattered across the cosmos, like watching shadows of an invisible monster. Number 3, exoplanets and possibly life. Roman carries something called the coronagraph instrument. It is a starlight blocking machine of extraordinary precision. It blocks the blinding glare of distant stars so we can actually see the faint planets orbiting around them. We're talking planets that are 1 billion times fainter than their host star. To put that in perspective, imagine trying to see a firefly hovering next to the sun. That's what this instrument can do. Roman is expected to find thousands of exoplanets, including ones orbiting in the cold outer regions of solar systems, the kinds of places where in our own solar system you find Jupiter and Saturn, the kinds of systems we've barely been able to see before. And maybe, just maybe, somewhere in that data, a world that looks a little familiar. So when does it launch? Here's the exciting part. Roman is done. Construction finished on November 25th, 2025. It's fully assembled, sitting in a clean room at NASA's Goddard Space Flight Center in Maryland. It completed vibration testing, acoustic testing, all the scary please don't shake apart when you ride a rocket tests. And the news just keeps getting better. As of 2026, the project is described as ahead of schedule and under budget. NASA official Sean Donegal-Goldman literally said, "The Roman team has proven that we can do flagships on time and on budget." It is scheduled to ship to Kennedy Space Center in Florida in summer 2026 and launch on a SpaceX Falcon Heavy rocket as early as September or fall 2026. It'll travel to a point roughly 1 million miles from Earth called L2, the same neighborhood where Webb lives. And once it's there, within 5 years, it'll show us more of the universe than we've seen in all of human history combined. The drama. NASA almost killed it. In April 2025, the government proposed cutting NASA's science budget by 47%, and on the list of things to cancel, the Nancy Grace Roman Space Telescope, a $4 billion project that was almost completely built, already paid for, already in a clean room. The proposal was met with what you might politely describe as absolute chaos in the scientific community. Thousands of researchers, dozens of organizations, nearly 100,000 messages flooded Congress. Bipartisan outrage, which in 2025 was rarer than a clear sky in London. And Congress, in a rare moment of doing the right thing, said no. The F wants a 2026 budget passed by Congress actually funded Roman at $300 million. Twice what the White House requested. The bill included explicit language protecting the mission. One congressional report called Roman ahead of schedule and under budget and essentially told the administration, leave this one alone. So yes, the telescope survived political assassination attempts, 2 government shutdowns, a pandemic, and the standard please don't cancel science anxiety that plagues every major NASA mission. It's launching this year. Who even is Nancy Grace Roman? We need to talk about the woman it's named after. Because this is a story that should have been a Netflix series by now. Nancy Grace Roman was born in Nashville in 1925, and from the time she was a little kid, literally 10 years old, she was organizing astronomy clubs for her friends. While most kids were collecting baseball cards, Nancy was out mapping constellations. She knew by high school she wanted to be an astronomer, but the universe, or at least like the humans in it, had other plans. Her guidance counselor literally asked her, a college professor told her, and I'm not making this up, he usually talked women out of going into physics, but that she might make it. He said that like it was a compliment. And she was denied tenure at the University of Chicago simply because she was a woman. So what did Nancy Grace Roman do? She ignored every single one of them, got her PhD, joined NASA in 1959, just 6 months after the agency was founded, and became the first female executive in NASA history, the first chief of astronomy, the woman who, from scratch, literally built NASA's entire space astronomy program. And then she spent years fighting politicians, convincing skeptics, writing congressional testimony, attending dinner after dinner, making the case for one big, audacious, impossible idea, a telescope in space. That telescope became the Hubble Space Telescope, one of the most important scientific instruments in human history, and it was Nancy Grace Roman who made it real. Her colleague Ed Weiler, Hubble's chief scientist, gave her the nickname that stuck forever, the Mother of Hubble. She passed away on Christmas Day, 2018, at 93 years old, never quite seeing the full fruit of what she started. But in May 2020, NASA named their next great telescope after her. And honestly, it's the least they could do. She built NASA's astronomy program from nothing. She fought for Hubble when nobody believed in it. She spent decades lobbying, convincing, writing testimony, arguing for the idea that humanity deserved better eyes on the universe. And now, there is a telescope, a $4 billion universe mapping, dark energy hunting, exoplanet finding machine bearing her name, set to launch into the cosmos this year. That is genuinely one of the most beautiful things about science. The work outlasts the doubters. Roman is going to show us 1 billion galaxies. It's going to map dark matter. It might find worlds that look like home. And it might, just might, finally tell us why the universe keeps expanding faster and faster into whatever comes next. If you made it this far, you're exactly the kind of space nerd I built this channel for. So hit subscribe if you haven't already, drop a comment with what you think Roman will discover first, and share this video with one person who only knows about Hubble. Let's fix their education. I will see you in the next one.